Okie doke. We are doing Advent of Code Day 8 in barely competent, maybe not quite competent Rust. Let's see how it goes. Today's problem is called the 7-segment search. Oh boy, I'm already looking at this kind of like ASCII graphic here and I'm getting scared. You barely reach the safety of the cave when the whale smashes into the cave mouth, collapsing it. Sensors indicate another exit to this cave at a much greater depth, so you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7-segment displays in your submarine are malfunctioning. They must have been damaged during the escape. You'll be in a lot of trouble without them, so you'd better figure out what's wrong. Each digit of a 7-segment display is rendered by turning on or off any of the 7 segments named A through G. I'm actually kind of curious about this. I've never heard of these kind of displays called 7-segment. I mean, obviously, everybody has seen these, especially in like LCDs and that kind of thing. But there are indeed 7 segments. Interesting. Okay. So there's segments A through G. They look like this. I guess 8 is the best illustration of them. So to render a 1, only segments C and F would be turned on. The rest would be turned off. To render a 7, only segments A, C, and F would be turned on. The problem is that the signals which control the segments have been mixed up on each display. The submarine is still trying to display numbers by producing output on signal wires A through G, but those wires are connected to segments randomly. Worse, the wire segment connections are mixed up separately for each 4-digit display. All of the digits within a display use the same connections, though. So you might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. Only the digit that uses 2 segments is 1, so that must mean segments C and F are meant to be on. With just that information, you still can't tell whether wire BG goes to which segment CF. For that, you'll need to collect more information. For each display, you watch the changing signals for a while, making note of all 10 unique signal patterns you see, and then write down a single 4-digit output value, your puzzle input. Using the signal patterns, you should be able to work out which pattern corresponds to which digit. For example, here's what you might see in a single entry in your notes. ACEDGFB, CDFBE, GCDFA, FBCAD, DAB, blah, 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 blah. The entry is wrapped here to 2 lines so it fits. In your notes, it will all be on a single line. Each entry consists of 10 unique signal patterns, a pipe delimiter, and finally the 4-digit output value. Within an entry, the same wire segment connections are used, but you don't know what the connections actually are. The unique signal patterns correspond to the 10 different ways the submarine tries to render a digit using the current wire segment connections. Because 7 is the only digit that uses 3 segments, DAB in the above example means that to render a 7, signal lines D, A, and B are on. Because 4 is the only digit that uses 4 segments, E, A, F, B means that to render a 4, signal lines E, A, and F, and B are on. Using this information, you should be able to work out which combination of signal wires corresponds to each of the 10 digits. Then you can decode the 4-digit output value. Unfortunately, in the above example, all of the digits in the output value use 5 segments and are more difficult to deduce. For now, focus on the easy digits. Consider this larger example, blah, 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 blah. Because the digits 1, 4, 7, and 8 each use a unique number of segments, you should be able to tell which combination of signals correspond to those digits. Counting only digits in the output values, the part after pipe on each line, in the above example, there are 26 instances of digits that use unique number segments, highlighted above. In the output values, how many times do digits 1, 4, 7, or 8 appear? Okay, so we've got kind of like a logic puzzle going on here. I guess I don't know if everybody's familiar with the logic puzzles where you're talking about different people standing at a cocktail party and like Jack is wearing blue and his sister is not wearing red and like Jane is wearing purple. You kind of have to like combine all these different facts together to kind of like figure out how they align. And it seems like this is sort of like another version of that kind of thing, which seems really fun. This is the type of programming problem I feel like is something where you can work it out on pen and paper relatively easily. I'm not sure if it's easy in this case, but writing an actual computer program to sort of like actually hash out your logic is a super interesting exercise. I always feel like a good way to practice programming is just to do something that you know how to do by hand or in your head, but spell it out in code. Because oftentimes some of the trickier programming problems that we run into are exactly that exercise. Well, you kind of have an idea of how you want to do it, but actually translating into code is the difficult part, modeling it using programming constructs and data structures. This is a rather convoluted question. And the output value is how many times did digits 1, 4, 7, or 8 appear? I think they're asking this because they're setting us up to basically say, like, they're basically setting us up to determine what the actual 4-digit value is at the end. But this first question is just asking us how many times did the digits 1, 4, 7, and 8 appear in the output values. Let me just take a look at this really quickly. Okay, gosh. So there's lots of different examples here. So I think each sample, each line here, means that there's a different random assignment that is random but still unique. Okay, so let's try and figure this out. I'm guessing that there is enough information in a single sample I wonder if there's enough information in here for us to like know for certain what the 4 output digits are going to be. It's kind of like an algebra problem. Like, you have a lot of unknowns. Do you have enough like known constraints to get to the number of unknowns that you have? And I'm not sure if I can tell by a glance, just thinking about it. Okay. This is complicated enough that I think I'm actually going to try to start with the sample input here. This larger example, and then kind of like work through it and make sure I really understand what's going on here. Although actually, trying to determine what digits 1, 4, 7, or 8 or 8 look like, that's actually relatively easy, because essentially what you're saying with the 1 is you're basically saying how many digits in the output have 2 letters. For a 4, what does a 4 look like? How many digits in the output have 4 active signals? Because nothing else uses 4. For 7, 7 uses how many? 3, and then 8 uses all 7 of them. 6 and 9 use 6 signals. 5 uses 1, 2, 3, 4, 5 signals, as does 3, and as does 2. And then 0 uses 6 signals, as does 6 and 9. It's interesting that 6 uses 6 signals and 5 uses 5 signals. I don't think there's really too much significance to that, but it's just kind of interesting that that's a coincidence. So just for my notes, I'm going to write down that 0 uses 1, 2, 3, 4, 6 signals. 1, 2 signals. 2 uses, what did we say, 5 signals? 3 uses 1, 2, 3, 4, 5 signals. Is that right? 1, 2, 3, 4, 5. Yes, 3 is actually just looks like 2, but you just moved 1 over. 4 uses 1, 2, 3, 4 signals. 5 uses 5 signals. Wow, so it's not just 5 and 6, 4 as well. I wonder if the origin of those numbers, when people were drawing them, they were drawing them with sticks like this. It's interesting to think about, because like 1 is just like obviously 1. 2, on the other hand, 2 doesn't really look like 2 straight lines any way you slice it. Okay, anyways. 6 uses 6 signals, 7... No, wait, 4 uses 5 signals, right? Let's take a look at that. 1, 2, 3, 4. Oh, wait, this is 4. 4 is 4. 7 is 3 signals. 8 is all 7 signals, and then 9 is 6 signals. I think these will be useful notes for us to have on hand. Because of this, I think we can just like get our full input here. I was initially worried that this first problem would be really, really hard to solve, but I actually think all it is just basically looking at the output column here. So that's this stuff. And then just saying, for 1s, does anything use 2? For 2s, for 4s, does anything use 4? For 7s, does anything use 3? And for 8s, does anything use 7? Okay. So what we're going to do is we're going to grab our input, get input. We're going to get it in lines. We are going to, for each of those lines, we're going to split the lines on the pipe space string. And what we want is like the second thing in this split. So I think, what does next do? Next advances the iterator, returns the next value. If I call next on an iterator, I think I want next.next. How do I advance an iterator twice and get the second value? There are people who are really good at these kind of like Rust dot chain things, but like, let's just look this up. Rust gets second value from iterator. And maybe there's just some magic function that will, how can I skip the nth element? How can I skip to the nth element? Partial to filter map. There's iter tools. I don't really want to bring in another, I can do like skip 1. Dot next. That'll give me that value. And so what this will give me is just this string here. So let me actually just try to print out what I've got so far. Let's try debug. Unused map. I guess I need to collect this. And let's let it know that I want a vec of strings. Or even a vec of references to strings. I think that's what it might be. Cannot be built from options, so let's unwrap here. All right, let's go ahead and compile that. BEGF DEC GFA. BEGF DEC GFA AEG. Okay, that's great. I think our skip was what I wanted. ABF CDEG. ABF CDEG. Let me make sure if I can. Okay, cool. My audio settings are correct. I just want to make sure I can hear notifications in case anybody pops into chat. I don't know who's going to do that in the middle of the Wednesday right before lunch, but you know, you never know. Okay, so we're writing this correctly, and then what we actually want to do here is we want to actually this is actually going to become a little bit more complicated because we don't just want the string, we want to map this, we want to split this along spaces. I actually think we have a kind of fancy, does it know where I am right now? I think I'm just missing a parentheses. Split ASCII white space. This gives me some tokens, and what we're going to do is we're going to map this. We're going to get some substring or token, and then what we want to do is just want to get the length of that token, and that will tell us just how long each of these tokens is. Right. Oh, and then I still need to collect it. And we are going to collect this into a vector of len, I believe, just returns a usize, right? Is that correct? Yeah. And I think I have misplaced one parenthesis. Let's see, I've got a map here. This map is closed, and then I collect over that, and then I close that map, and then I write to the debug. Still doesn't like it though. It's expecting an expression of some kind. What happens if I get rid of the debug here? Because I think I've properly made a mess of this giant dot chain. I think I'm just missing a closing angle bracket there. Oh, and then I still have the problem of needing to collect these at the very end. Collect. And this is a vector of usizes. One more. Okay, that's cool. So it looks like my output is long enough that like it's exhausting the Visual Studio Code terminal buffer. I probably need to expand that. But if I just take a look at the input, let's just take a look at the very last thing. I've got a thing that has 7 characters, or 7 signals that are active, 7 signals that are active, 5 signals that are active, and 6 signals that are active. So I think that's exactly what we wanted. Now, the question, once again, if we can refresh our memory, is that just in the output values, how many times do any of these digits, 1, 4, 7, or 8, appear? Oops, didn't mean to close that tab. So I think what we really want to do is I guess rather than going to token.length, what we can do is just filter this. We're filtering our tokens. And we're going to match on token.length. And if we have a 1, 4, 7, or 8, so if we have basically 2, 4, 3, or 7, it's true. Otherwise, it's false. Is it having a hard time with a match right here? Do I need to add extra curly braces? Or do I separate these by pipes? What is the match syntax, if not commas? Yes. And do I need these curly braces? Don't. Okay, now that we filtered that down, we just need to sum over these. This will tell us in a single sample how many 1s, 4s, 7s, and 8s together do we have. Not sum, count. And then we're going to sum all of those. Type annotations need needed. Is it over the? It's not over the count. We filter these. Gosh, I wish this error message was a little bit more specific. I guess it's saying line 15, but line 15 is the entire debug, which is a little bit cumbersome to work with. So let's start breaking this apart. It looks like it's the sum that it's having a hard time with. Cannot satisfy sum of a U size. I mean, what if I just did this count as I64? Just cast it. Sum's the element of an iterator, and the iterator is of an I64. Let result equals this. I'm a little bit skeptical that this was necessary, but and it makes me worried that I have some kind of like weird syntax error there, but let's just check it out. 288. Okay, well, we did it correctly. Hopefully that wasn't just an accident. I may clean up this code a little bit. 2 is a 1. 4 is a 4. 3 is a 7. And 7 is an 8. Is that too weird looking? It is a little bit weird looking. I'm not exactly sure how I should format this otherwise. And it looks... How about this? Just so I can stay sane, I think what we really mean is a 1... Actual digits is 1, 4, 7, 8. And I believe we're still running correctly. Okay, so we've got part 1 done. I'm going to go ahead and commit that to our repository. And let's go ahead and just copy. Oh, shoot. I kind of messed up the repo because I think I might have edited the README or something like that online. So let's just make a branch locally here. And we are going to fetch. And let's rebase over origin main. And we're going to reset to foobar, and then now we're going to push. And that should give us a nice log. Yeah, I think I made some edits to the README directly on GitHub. Okay, now that that's there, let's go ahead and copy our current solution into part 2, part B. I don't know how much code we're gonna keep. Probably not a whole lot of it, but at least the parsing stuff is a good foundation. So part B compiles is just giving us the answer to part A because that's what we wanted. I'm going to reload my editor because when I add a new directory, the language services don't know that it's there until I reload. So what scary question is part 2 going to ask? Through the deduction, you are now able to determine the remaining digits. Consider again the first example above. After some careful analysis, the mapping between signal wires and segments only makes sense in the following configuration. And that's this example here. So the unique signal patterns would correspond to the following digits. Blah. Then the 4 digits of the output value can be decoded. Yes. Therefore, the output value for this entry is 5353. Following the same process for each entry in the second, larger example above, the output value for each entry can be determined. Adding all the output values together in this larger example produces 61,000 blah. For each entry, determine all of the wire segment connections and decode the 4-digit output values. What do you get when you add up all of the output values? Okay, nice. Okay, so you know how like earlier I was wondering, you know, do we have enough information in the kind of like garbled but unique output? to determine in all examples what the assignment from signal to actual kind of location in the 7-segment digit is supposed to be. And they're saying, yes, you definitely have enough information. And while this would be easy to kind of suss out for one of these lines, we definitely don't want to do each of these by hand. This is why we want to automate the sort of process. So we basically need to be able to do process of elimination using code. Okay, so we need to, I think, enhance our parsing a little bit more effectively. I'm trying to think of the right way to do this. I guess we can just have a bunch of, like, do I want to keep each sample in its own structure? Or do I want to keep all the inputs in one array? You know, it doesn't really matter. I think having one structure maybe just makes a little bit more intuitive sense off the bat, even though it might not be the most efficient thing. But I think, yeah, let's call it the sample. And the sample is going to have, what is the example calling this first column of data? It's patterns and output, right? So patterns is I guess theoretically we could call it an array of vectors. Let's just do a vector of, it's really just a vector of strings, right? I'm trying to decide whether it'd be easier for me to treat this as a vector of characters. I think strings are easy enough to iterate over for characters. You just do string.char. So I'm going to do this. And then output similarly is a vector of strings. And I believe it's asking me to add a comma here. Impl from string for sample. We're just going to write a little parsing function here. And I wrote down some notes on how to do parsing in my README, because otherwise it would just be very easy for me to get confused. We're not going to need regular expressions, I'm guessing, so this lazy static can go away. And what we're going to do is for this string, this is one line of input, we're going to go ahead and split it, let iter equal s.split along a space pipe. And then we're going to say that the pattern string is equal to iter.next, and let output string equal iter.next. And let's unwrap these. We know that the input is well formed, and if it crashes, then that's a good thing. So now the sample of this patterns, I mean, I don't even need this temporary. I can just do this, and I'll split it by I will just split it on white space, right? And I think if I just call collect, is it going to know what to do? Wow, it kind of does. Let's call the iter impl from string, cannot find from string. I'll go ahead and import that. Just because I know I'm going to need this. I'm going to derive debug clone and I don't know if we need to clone and copy. This is actually something we may want to be deliberate about, but we'll see. Collect, it's having a hard time with, because I think I need to basically just like turn these into strings. So if I map over these, s.toString, that should take care of that issue, and then I need to just repeat that mapping for the output as well. Can I borrow chunks as mutable? Yeah, I need a mutable iterator here. I feel ya. All right, so now that we've done that, when we map over these lines, what we're really just doing is parsing them. And so what we're going to do is let samples equal get input dot lines dot map line dot parse dot unwrap dot collect. And it's going to give me some typing errors here because it doesn't know what it is. And what it should be is a vector of samples. And just to make sure that we did that right, let's go ahead and just debug print it. I'm just going to take a look at this very last one. The very last one, the first signal is GBA, Game Boy Advance. EAG BCF is the second one, GB, it goes all the way to ADEG FB there, that's good. And then we have 4 of these things. Okay, this looks like my parsing is looking pretty good, which is nice, which is really nice. Okay, so now comes the actual hard part of coming up with an algorithm that will essentially let us do process of elimination. And it's going to involve kind of like special knowledge of each digit. So we are essentially talking about some one-to-one mapping of segments A, B, C, D, E, F, and G in their true nature, and symbols A, B, C, D, E, F, and G as they appear in the randomized output. And we just have to figure out what that mapping actually is. So there's got to be, I think, for each one of these rows, each one of these samples, we can come up with essentially a lookup table, like a hash map of the random sample to its original value or vice versa. I do wonder a little bit if we're going to get confused because we use the same symbols to represent the true thing and the false thing. So I wonder if there is something we can do to make that a little bit less confusing. So maybe what I can do is, I don't know if this is actually useful, but I'm going to create an enum called true signal. And then just create A, B, C, D, E, F, G. And let's go ahead and do copy and clone for these. Variant is never constructed. Okay, that's fine. It's just complaining that I don't actually do anything with those. And this is gonna be my true signal, and then the sort of like random garbled signal for each sample is just a character, you know, corresponding to like the lowercase letter A through the lowercase letter G. That hopefully will make it a little bit less confusing for us, but I'm not 100% sure. I'm just gonna pick the first one of these at random. And I want to create a new text file and just really kind of dig in and try to figure out how it works. And then the other thing I want to grab is a diagram. And that diagram is this one here. Actually, we really only need the one for the number 8. So I'm going to go ahead and just like paste it up here and then just try to get rid of the rest of this stuff. You know what? I'm just going to keep this whole thing. We might as well just like have it all here as a reference. But what I will do is go to the capitalize. Is there any kind of like all caps thing in VS Code? Certainly in Sublime Text there is. But uppercase, transform to uppercase. That's great. And the reason why I did it in uppercase is like this is basically representing my enum of the true signals or true segments. I should call this a true segment or canonical segment, whatever we want to call it. Actually, I like canonical. It's more words. It's more characters, but it'll help us differentiate from other the actual sort of random characters. Okay, so what's our kind of deduction going to be? Doing deduction and process of elimination in programming is always like kind of super interesting because it involves kind of like just like creating a list and then shaving it down. And again, it's like stuff that like I think is like relatively doable if we just did it on paper and pencil, but actually describing it, our process in code becomes difficult. So maybe what we can do is we could create a list for every single true canonical segment of the possible characters that they represent, or vice versa. For every single character, lowercase a through lowercase g, what are the possible true segments that they represent, right? And we can start by looking at like the 1s, the 4s, and the 7s. So if we look at 1, which is EG, this means that E can either be canonical segment C or canonical segment F. The next one up is AEG, which I believe has to be the 7. And that here means that the A can be any of true segment A, true segment C, true segment F. E can be any of those 3. And G can be any of those 3. Then we go to the 4-letter one, which is the digit 4. And that can be any of, so G can be any of, it's B, C, D, F. Right, and this is the same for F, it's the same for B, it's the same for E. Yeah. And then finally we go to the, I believe it's the 7-character one, which I think is this one. And the 7-character one is the number 8. And the number 8 is all of those, right? It's like A, B, C, D, E, F, G. So E can be A, B, C, D, E, F, G. This actually adds no extra information because you're going to have A, B, C, D, E, F, G in the 7-character signal. I think basically this sample just doesn't give us any extra elimination. It doesn't provide any information that is useful to us. Whereas actually this one, because it's so few letters, gives us the best possibility, right? Okay, so can we just kind of mechanically go through this? What's interesting is that whatever algorithm we come up with in this example should more or less represent the same algorithm that we'll do for anything. Because like the fact that we use these different letters, I feel like they're all 100% interchangeable. Although the assignments are not always going to be the same. So we'll see here. Like the fact that A is adjacent to B is adjacent to C doesn't matter. Like the sequence of these characters doesn't matter. These are just names for completely unique things. And so I think again, just restating what I just said, the algorithm that we come up with here in this specific example, we should be able to apply it generically to everything. So each of these lines that I've stated here, we can essentially do the set union for, like, let's say the lowercase character e here, and the set union for this one. And the question is, does that actually give us any additional information? Like if we do the union, or the set intersection rather, the set intersection of the lowercase letter e is C and F. And then if we do the set intersection here, we also get C and F. And then for E, we also get C and F. So it doesn't actually reduce the problem down. But if we do it for G, C and F, C and F. So we may actually end up having to kind of look at the other character lengths. So we're going to have to look at basically other digits besides 1, 7, and 4. We'll have to look at the digit representing 2, which has 5 characters, and the digit representing 6, 9, and I think that's it. It's 6 and 9, right? That have 6 signals, 6, 9, and 0 as well. Okay, so maybe another thing that we can do is, like, just looking at the pattern here, are any of these segments like ones that we want to, like, especially focus on? Because they're going to be present in every single, in maybe digits that have, like, the common count. So for example, 6 and 9 and 0 have 6. Are there any that just have, is there a signal count that only is present in 2 digits? Maybe it's 5? No, 5 has 3. So the fewest is 3. There's only 1 there. 4 only has 1. 5 has 3. 6 has 3. 7 has 1. All right. That kind of sucks because it basically means that the elimination is just a little bit more complicated. Okay. What if we were to compare two of these doesn't really do anything for us here. Boy, day 8. I think this is already, I think either I haven't seen the trick yet, or this is already just like the most difficult problem in admin code, which is not a complaint. I'm glad it's getting tricky. I just hope I can get it done in a reasonable amount of time so I can have a lunch and get on with my working day. What about a frequency analysis? Like, for example, let's look at one of the true segments. Are there true segments that appear a specific number of times or unique number of times in each digit, right? So let's just take across all the digits, rather. Let's just take true segment A, right? The frequency count of true segment A is 1, 2, 3, 4, 5, 6, 7, 8. I wish there was something in the editor that told me how many little chunks I've just highlighted, right? 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 of those. For true segment B, there's 1, 2, 3, 4, 5, 6. For true segment C, there's 1, 2, 3, 4, 5, 6, 7, 8. So far, not looking good in terms of uniqueness. For true segment D, 1, 2, 3, 4, 5, 6, 7. For true segment E, 1, 2, 1, 2, 3, 4. Is that right? 1, 2, 3, 4. The vertical ones are a little bit harder for me to read. True segment F, 1, 2, 3, 4, 5, 6, 7, 8, 9. And for true segment G, it's 1, 2, 3, 4, 5, 6, 7. Okay. We have 8 and 8. 6 looks unique. And 4 looks unique. Right? So what I'm proposing here is we count the number of letters that appear in the input signals, input patterns. And right away, we find the letter that appears 6 times. And that's going to be true signal B. And we find the letter that appears 4 times. That's going to be true signal E, right? Okay, that gives us a lot, right? Let's see, B and E. B is here, E is here. So it's basically the left-hand side, left-hand vertical lines. Okay, so now I think what we can do is kind of take a look at where those appear in the digits that aren't trivially easy to identify because of the number of characters that they have. Because we already know what B and E are. And we also know what the one for 7 and 8 are, right? We know what sets of segments, what sets of like randomized signal characters are in 1, 4, 7, and 8. Boy, it's really, really difficult to navigate all the different facts and different terms in this problem. And if anything, like math and programming are about just using really specific terms and being clear about that. So as we're trying to think through the program, what we're really trying to do is just think through our terminology and think through our concepts, right? So, okay, what I'm saying is that we start with the idea that we already know which character goes to true segment B and which character goes to, canonical segment E. We'll be able to determine that just by doing frequency analysis. So what does that give us? And let me copy over this piece of information here because I think it'll also be useful for us to look at together. So if we know B, what happens if we know E? 1, 2, 3, 4, 5. Which ones have 5 again? 2, 3. 2, 3, and 5 have 5 segments. 2 has an E in it. So because we know which letter is E, we can find the digits, the input patterns that have 5 segments in them. And we'll know which one of those is the number 2. And since we know which one has B in it, because that's 5 has B, we'll know which one is 5. as well. So we will know, we'll do frequency analysis first. So A, do frequency analysis. We know, now we know which characters are segment B and segment E. Use the 5-segment pattern with the character for segment B is digit 5. I'm not gonna, why am I ordering these? I'm just gonna use bullets here. The 5-segment pattern with the character for segment E is the digit 2. What else can we know? What about the one with, I guess the ones with 6 characters, which is 0, 6, and 9. The 6-segment pattern without character, without the character for segment E is digit 9, right? Because 9 doesn't have segment E in it. And then B is actually present in both 0 and 6, so that's not going to tell us anything. What about the other characters that have B in it or E in it? I think we've done the analysis for the character E. Now let's look at B. B is present in 4, but 4 is unique, so that doesn't tell us anything. B is in 5, 6, 8 we don't care about. So it's really differentiating 6 and 9. Okay, 6 and 9 both have 6 characters in them. And 0 has 6 characters in them. We know which one is 9. So we're now trying to differentiate between 0 and 6. They both have B in it, so that's not helpful for us, right? However, the 6-segment pattern that is not digit 9, that and has the 2 characters from the digit 1, which we know just by counting them, is 0. So we know from just this like deduction, we'll know off the bat 1, 2, 4, 7, and 9. From this deduction, we'll know 0, 2, 9, and 5, which leaves us with 3, 4 we know, 5 we know, 6 we don't know yet. So it leaves us with 3 and 6. The remaining unknown digit with 5 characters is 3. Wait. How many have 5? 3 does. 2 does. Oh, the 5-second pattern is... Okay, so we actually know the remaining unknown 5-segment pattern is digit 3 by process of elimination, right? So we know 1, 2... We know 1 because just of the number of characters in it. We know 2 from here. We know 3. Okay, first of all, we know the 2-segment let's be really, really thorough about it. The 2-segment pattern is 1. The 3-segment pattern is 7. The 4-segment pattern is 4. The 7-segment pattern is 8. So we do frequency analysis, and now we know which characters are segment B and segment E. The 5-segment pattern with the character for segment B is digit 5. The 5-segment pattern with the character for segment E is digit 2. The remaining unknown 5-segment pattern is digit 3. The 6-segment pattern with the character for segment E is digit 9. The 6-segment pattern that is not digit 9 and has the 2 characters from digit 1 is 0. So now we know 0. We know 0, 1, 2, 3, 4, 5. We don't know 6, 7, 8, 9. So the remaining unknown 6-segment pattern is 6. Okay, so this gives us a kind of like algorithm for figuring this out. So I'm going to go ahead and just like paste that in here. Okay, so what we want is a mapping between, well, we could have lots of different mappings, and I think juggling in between them is going to be the confusing part. I wonder if in Rust there's a way of doing a unique mapping type, where there's hash maps, but the values don't have to be unique. Rust unique map. Is there such a thing? Rust hash map with unique. I love how when I Google for Rust, I get a bunch of Rust video game stuff. I think that's the common bugbear for everybody working in Rust. Because the video game is super popular and probably more popular than programming language. Rust hash map with unique values. Is there such a thing? I guess it doesn't matter. It's really just for covering my own ass. It would be easy to kind of like, I think, create a data structure to do that, but not easy enough that I want to do it right now. So we want to know which pattern is 1. So the patterns are just strings, right? So let string to digit, which is a hash map of, let's just say string references. We're going to regret not using an actual string there. Let's see. String references to digits. And for digits, I'm just going to use U8 here. Is a new hash map. New. And let's just iterate over the samples for s in samples dot iter. Let's go ahead and say, let's match the samples patterns dot length. This is oh, you know what? I think we just want to do the first example, right? We'll basically just try to suss out the first thing, and we'll do it on the sample input because I think it'll be enough for us to just try to figure out like how the sample input is doing, rather than just like, this is definitely one we'll maybe want to verify with the sample before we proceed. Let string to digit equals hash map new. So this is for this sample, and then for p in patterns in s.patterns.iter. What we want to do here is we want to match the pattern length. This is the length. Why is it having an issue here? Oh, it's just the parentheses, because I keep adding parentheses. I insist on having parentheses. It's the length of the string. If the length is 1, then string to digit of p.asString. We're adding this, string.add. Insert? Insert. All right. p.asString, we're adding 1 to that. Sorry, it's not 1. The length of 1 is 2. 3-segment pattern is 7. The 4-segment pattern is 4. The 7-segment pattern is 8. Enum option. Is this returning a result? Insert. I think it's asking me to add semicolons to all of these. While parsing the match arm starting here. Okay, finish the sentence. Oh, it's just expecting a comma here. And then it's having an issue with this last O because it's just auto-completed weird. And string to digit needs to be mutable. Underscore we don't care about. Okay. And so these all need to be statements. Is there a way I can just do a semicolon here? No, it's got to be a comma. So I think I was kind of resisting this, but I have to semicolon everything. I wonder if there's just a way to drop this. Ignore. Using a dot pattern. Because I don't love these braces here. Just so I can add a semicolon. I mean, really, this could just be an if-else ladder at this point, just given how messy this looks. I wish there was a way around this. I mean, I could just create an option here that evaluates to nothing. I wonder what the idiomatic way of dealing with this particular thing would be. Okay, so we at any rate, we've basically been able to kind of like create a mapping between our strings and the numbers that we know for sure. Okay. In fact, let me actually put this inside the iteration here. Okay, now we want to do frequency analysis. Frequency analysis is going to tell us let mute char counts by char, and this is going to be a hash map of characters to frequencies, which we can use U8 again. Again, I said this before, but I'm not really certain. I don't really have a really rigorous philosophy of when I use U8 versus. I guess I should probably just use I64 when I don't care, right? That might be a better way of thinking about it. Like a digit is probably going to be like a value from 0 to 9. But I don't really care, right? The only times I really care is when I'm serializing or sending things over the wire. I really do care about the sort of like underlying representation. Anyways, I'm not gonna like spend too much time fretting about it. So we want to do frequency analysis. What was our frequency analysis again? Like, B has 6. Look, segment B will appear 6 times. Segment E will appear 4 times. So we're counting each character, right? Let's say char. Let char, the character for segment B, is equal to, let's just call it A for now. We know that that's not true, or not necessarily true. Segment E is equal to A, also equal to A. These can't be the same. And then let's just iterate over each pattern for P in s.patterns.iter. Actually, let's just iterate over characters for C in A to G. We are going to, over this patterns, we are going to filter we're getting some string for this particular pattern, right? Or let's call it P. P dot contains a certain subslice. The subslice is C. And we're going to sum those, right? And we're going to match against this. And if we get 6, we know that char segment B is equal to C. And if we get 4, we know that char segment E is equal to C. Otherwise, we don't care. This might be a funky way of doing it. Can you not sum over this? Or count, actually. It's what we want the count. So basically, we're just going over every single character that we know exists, A through G. And this expression counts the number of times that particular character appears in the patterns. And if one pops up 6 times, we know that that's the one that corresponds to B, and otherwise we know that 1 corresponds to C. I actually think that maybe a better way of doing this is we're going to say let mute segment by char, which is a hash map of a canonical segment. No, the by char means that the char is the key. And I don't know which is the key and which is the value. Again, this is sort of a bidirectional mapping here. And there may even be a function that will allow us to kind of like reverse the relationship between it for a hash map. What we're actually doing here is we're saying that segment by char, we're going to insert C, and it's going to be canonical segment B, right? And theoretically, we can actually continue the for loop here, right? And I think continue match doesn't really affect continue, so continue should jump up to the next character. This isn't the prettiest code that I can think of. It is actually the prettiest code I can think of right now, but it's not the prettiest code I can imagine being in here. And this is canonical segment E. And here we can also continue. Otherwise, we don't really care. This is complaining because I haven't, it's non-exhaustive. That's fine. Do nothing. Semicolon. All right, let's kind of like put all of our collections here. Okay, this will tell us what E, B, and E are. And if we wanted to, we could probably write a kind of like assertion here that the values are unique, but I'm not going to bother with that for right now. Okay, the 5-segment pattern with the character for segment B is digit 5. What we are ultimately hoping to fill out is string to digit here. Because what we can do is we can plug the output values in the column into digits and then just like convert that into an actual decimal value. The 5-segment pattern with the character for segment B is digit 5. The character for segment B, so it actually seems like we want to reverse these because here we're going to be looking up the character using segment B. So I'm actually going to call this, let's rename, char by segment. And let's go ahead and reverse these. Char by segment means that the key is the canonical segment. And that should give us type errors down here. That just means we need to reverse these two. I'm still having an issue here. Insert. We can't hash this. We need to derive from canonical segment hash and equals, partial equal and equal. The 5-segment pattern with the character for segment B is digit 5. So we need to know patterns by segment length. Okay. So let's 5-segment patterns equals, and let's just call that a hash set of strings, is equal to s.patterns.filter.iter.filter. Predicate is going to be the length is equal to 5, and we're going to collect that. Can we collect into hash? Oh, we need to map it as string. Okay, so those are our 5-segment patterns. So we can assert that there should be 3 here. Is there an assert bang? All right, we're gonna just do an easy assertion here just to keep ourselves sane. And if we're gonna do that, we should assert here that char by segment is equal to 2. I don't usually do assertions when I program, but it feels like here, doing some amount of sanity checking, I think reinforces some of our logical assumptions because this is so finicky. I do wonder if there's just like a radically simpler way of doing this that I'm not, because I'm literally just like mapping out the deduction exhaustively here, which I don't love. There's probably like a query language that we can do this really easily, or constraint solver that can also do this really easily, but that's not my forte, unfortunately. So string to digit, the length should be 4. We should have found all of these by now. Okay, so we've got the 5 segment patterns. The 5 segment pattern with the character for segment B is digit 5. Okay. So, we're going to iterate over our 5 segment patterns. For P in 5 segment patterns dot iterator, if the pattern contains char by segment of canonical segment It's complaining about my use of parentheses here. Then our string to digit dot insert, we are inserting the pattern string, and the value is 5. Oh, and this is : operating in a different language. Expects a reference. Yeah, okay, fine. And then we want to actually remove from the 5-segment pattern the pattern that we just had. Oh, and 5-segment patterns needs to be mutable because we're just basically trimming off of it. And P is bar by immutable. Oh, because we are iterating over them. Let's go ahead and collect these. And that will get rid of that. P is what? We don't, collect doesn't know what to do with here. So it is a vector. Let's do a vector of is it possible to iterate over entries in a hash table? Like iterate mutably over entries in a set. Rust hash set. Is there an entries thing in this at all? So this is interesting. We're doing a pattern where we want to iterate over all the values in a hash set, but potentially remove some stuff from it. I think it's okay if we just do this. Okay, fine. It's a double reference. Fair enough. And then it is also borrowed as immutable. So what if we... It's borrowing as immutable because the hash set owns the string? Is that what's going on here? Okay, so I'm running into kind of like Rust borrow checker stuff here, which is fine. Let patterns. This is tricky. So this is like 5-segment vec. That's terrible. 5-segment vec.iter and remove If I just dereference. So immutable borrow occurs on line 124. So it borrows from here. Okay. Gosh. Okay, this is what I was worried about with these kind of like references to strings. And it might simply just be easier to just call this a string. And we can clone the string. And let's just call this a vector of strings. This sort of pattern of like iterating over a container that you want to also modify at the same time is a thing I run into Rust a lot, just because I think it's probably the way that I think about programming. But maybe not. It's probably a habit I need to try to break. Okay, so we've satisfied the borrow checker by like basically brute forcing it. In fact, I wonder if I can just do this. Yeah, that's fine. Okay, P, what are you complaining about here? Type annotations. P, it doesn't know what it is. Oh, because collecting. Mutable borrow happens on line 1. Okay, so I do need to like, I think I need to just like stick this. itervec and this is a vector of strings. This is where I wish people who are experienced in Rust would be in chat right now, because they would really help me with doing this the correct way. iter.clone.collect, that's what I'm missing. P string, and it is complaining because P does not live long enough. All right, so string to digit, I'm also going to make a string here. And what all of these become are copies, which is fine. We're basically treating strings here as a kind of like value type. And while it's not a value type, we can basically simulate that by just cloning it everywhere, because that's essentially what we want. And indeed, this is probably what a lot of like kind of like, for doing this in a garbage collected language, this is probably what ends up happening, is that people like those systems will end up using either copy on write or just copying the strings when they insert them in as keys into a hash table. And now we don't have to do this. We can just, when we insert here, we'll just clone. Okay, so if this is for B, that wasn't much to do about that. We can continue. And then if it contains the thing for canonical segment E, it's digit 2, digit 5, digit 2. And then we're going to assert here that 5 segment patterns dot length, we should only have one left. And we are going to insert string to digit of 5 segment patterns dot remove, not remove. It's just, we're just going to get the last thing that's in there, iter.next.unwrap. That's the string, and then the digit is, in our comments, the digit 3. Oh, and I need to call an actual function here. Insert. And found a reference to a string. Let's just clone it. Yeah, we're just gonna clone strings everywhere. Gosh, there's a lot of code without running it, but that's the way the cookie crumbles. I'm starting to wonder whether I need this char by segment or if just 2 variables that I had before would be fine. I suspect that's probably what we can do. Okay, moving down a bit. This break is just so we only run on the first segment of it, first sample in the input. The 6 segment pattern without the character for segment E is digit 9. What is the character for segment E? It's this one here, char by segment E. Yeah, let's just say that like there's a segment B, and we're just saying that's A. Again, the A value is just like, I don't want to use an option here because I think it's just a little bit overkill. So I'm just putting in like let me actually put in a value that makes no sense, like Z, right? And then we can see, we'll just make some assertions that they're set correctly. So rather than inserting into a hash table here, we can just say segment B char, which is mutable, is equal to character C. And here the segment E char is equal to character C. And then we're going to assert that segment B char does not equal Z, which is our kind of sentinel value. And segment E char does not equal Z. Oh man, this is a hairy mess. And then char by segment should just be gone by now. Let's just blow it away. I don't think we need it. And this is just segment B char. And this is segment E char. The 6 segment pattern without the character for segment E is digit 9. So we need the 6 segment characters. And we're going to do some similar thing in here. Man, this pattern, I really don't want to repeat it. I suppose rather than remove, we could make another hash set of the ones we've consumed already, take the set intersection later on. How does that look in terms of code? Rust hash set intersection. We just get an intersection data structure back, which is an iterator, which we can then collect. Maybe that's okay. And then it'll allow us to let us not do this ugly thing here. So let mute used 5 segment patterns, which is a hash set of strings, equals hash set new. And then we're just inserting now. Insert p.clone. Now we're asserting that use 5 segment patterns, length is equal to 2. And then we are going to insert here not the intersection, the difference. Rust, hash set difference. difference. I wonder if they overload the subtraction operator. That's probably a little bit too cute. So what we're inserting here is we're taking 5-segment patterns, which no longer needs to be mutable. The difference between used 5-segment patterns. My autocomplete just totally died. Oh, and we're passing a reference to that in here. That gives us an iterator. We're going to go next, and we're going to unwrap it. This is going to be a little bit cleaner. Itervec. I don't think we need any more because this is just 5-segment patterns.iter. And then 5-segment patterns up here. Where do we even, no longer, it does need to be mutable because we're, oh no, it doesn't. Because we're only using it once. Great. And then why are you complaining here? Unwrap.clone. Gotta always clone these strings. I almost want a type that's just like a copy on write string. I guess lifetimes are still an issue there. Maybe not. I don't know. It would be nice to have something like that just out of the box. And that is the digit 3. Okay, so I think I slightly prefer this pattern. So now we want the 6-segment patterns. Equals 6. There are 3 of them. That's 0, 6, and 9. And then we're literally going to use the same subsequent pattern. And then anytime we say 5 down here, we got to replace with the word 6. I bet there's someone who just wrote this in like one line of Ruby. These terrifying beasts. Those 6-segment patterns. Okay, the 6-segment pattern without the character for segment E. Segment E char is the digit 9. And maybe it makes sense to just actually put these directly in here. This is 6. This is digit 0, and then this logic here is going to be quite tricky. Let's see. The 6-segment pattern that is not digit 9. Okay, it's a 6 that is not digit 9. Well, it's not going to be digit 9 because we're going to skip over it here. Right, if it was digit 9. So this one's covered and has the 2 characters from the digit 1 is 0. Okay, so what is 1? 1 is the pattern that has, I guess we have it in string to digit, but we got to reverse that. So we want to find let let. 1 is 1. 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 1 is we want to get the digits for 1. So if we go to our patterns, search for an element of an array that satisfies the predicate. The pattern is P, and 1 just has a length of 2, right? Dot unwrap. Let the 1 string equal this, and then let 1 chars, which is a vector of chars, equal 1 string dot chars. Excuse me. 1 string dot chars dot collect. Okay, and then maybe we can just do a giant 1 line of this. We're going to assert here that we don't need to make an assertion that the length is 2. We know for a fact that it's 2 here, right? We found it here. So if the pattern contains 1 chars 0 and contains 1 chars, I guess we could do an overlap, but you know what? This is a little bit clearer to what we're trying to say. Snake case. 1 char is 0, 1 char is 1, then we know that that's the 0. And we should have found both of those, and finally we have a 6. And then at this point, we need to assert that the length of string to digit is equal to 10. And what we can do at this here is just, I'm going to print out what string to digit actually is. And then it's complaining that I never construct A, B, C. When do I actually I don't even use canonical segment, do I? Yeah, didn't end up needing it. That's good, because it was a little bit silly. String to digit needs to be snake case. Oh, and I don't want to save my notes, really. And then what I will do is, I think... Nah. Now, I actually haven't double-checked my logic here. I haven't really run through it thoroughly. But I think we just live with it. Let's go ahead and iron out all of our warnings while we're here. Not using hash. Great. All right. So I said I was going to work with the sample input, right? And this is the moment of truth. I mean, that sounds super ominous. It's just my first attempt. There's no real moment of truth here. We can keep doing this until we really want to. Okay, we failed an assertion. Use 6 segment patterns length equals 2. Okay. That assertion is happening on line 168. So let's go ahead and print out our 6-segment patterns. And then let's go ahead and print out our used 6-segment. Can I debug using the reference? So our 6-segment patterns are here. Okay, so it looks like my analysis for 6-segment patterns is wrong, right? Because what's happening is there is a false positive on one of these. And let me actually make sure that this one chars thing is looking good too. Okay, my one chars are A and B. Is that correct? Yep. Okay, so let's take a look at our analysis again. So our 6-segment patterns are 0, 6, and 9. And what I said is that if you have, well, if you don't have an E without, okay, that's what I was doing wrong, is that it does not contain. Let's make that really clear. And if I run this again, hopefully it doesn't assertion fail. Okay, strings to digits. Let's take a look at the actual answer here. So ACD, yep, okay, that's 8. CDFBE is 5. GCDFA is 2. Okay, FBCAD is 3. DAB is 7. CEFABD is 9. Yes. CDFGEB 6. EAFB is 4. Yep. CageDB, it's my next startup idea, is 0. And AB is 1. All right, so it looks like from our sample, we got that correct, right? So we actually need to like spit out the actual answer to this thing. So we're gonna have a bunch of mappings from this gigantic friggin' for loop. We're gonna have a bunch of mappings, this string to digit, which is the result. But what we really want to do is we really just want to calculate the total value, right? So let result equals 0. Okay. And then what we're going to do, actually, you know what I'm going to do is I'm just going to make, you know how I was like kind of wondering whether I should use UID. I'm going to just make this I64 as my default. Like I don't give a shit about what the type actually is for my integer numbers. And this will just make it so that when I add and do math on these digits, I don't have to do any casting from U8 to like I64. All right. Okay, so what we're going to do now is that I can get rid of my debug statements, first of all. They were very helpful, but no longer needed. I thought about maybe doing these like used things by basically doing a collect over 6-segment patterns, where the collect, or rather the filter would return, a filter and collect. The filter would return true in these cases. But then like the filter would also be adding to string to digit here, which was weird. I generally think that when I'm dot chaining stuff, I really only want to be modifying one thing. And if I'm like building, like use 6 segment patterns at the same time that I'm building out this other table, it just feels strange. So I'd rather just like deal with it in an actual for loop. Okay, so now that we've got all the digits, what we can do is we can say that the result is equal to, let's take the first digit, which is in patterns, right? S.output 0. And we're going to be looking that up. String to digit of output 0 times 1000 plus, just going to brute force this. S.output 0 string to digit is a hash map of strings. So what do I need to do? Address of, or reference to, rather? Looks like. And then 1, 2, 3, 100, 10, and just for pretty, let's just do an actual println here. Come on, Jeff. And since we already have the sample input in here, oh hell. You know what, this is actually gonna be difficult to format. So let me just try running out of my original input. And if the answer is correct, it's correct. Otherwise, I need to do some debugging. Ooh, no entry found for key. On which line? 185, s.output. So let's just go ahead and print that. And reference probably. String, let's also print the string to digit. That is weird. Did I mess this up? It looks like this is a parsing error, right? Because the output seems to contain stuff. Oh, it is scrambled. I need to sort all of this stuff. I need to sort the characters. How annoying. Okay, the patterns are going to be, let's just sort them. Chars. How do I sort an iterator? Oh man, what a pain in the ass. Okay, so s.chars.collect. What are we collecting? We are collecting a vector of chars dot sort. And I think that'll type check, right? Oh, and these need to be converted back into strings. And is there a way I can sort and then dot chain off of that? Well, I'll just create the temporary. So let chars equals this, chars.sort, which means this needs to be mutable. and then chars.join. The separator is nothing, or the separator is the empty string. Following trait bounds are not satisfied. How do I do two? Do I just do like a two-string? Rust join vec of chars into string. Nope. Converting a array of chars to string. That's collect to string. Okay. I can dig that. Oh man, this should be trivially easy, and yet just the API is not super friendly, or I just not hitting the right thing. The method collect exists for struct vecchar, but its trait bounds are not satisfied by the following vecchar iterator. Oh, I think I just need to make this an iterator. Okay. I think it's literally the exact same thing here. But I'm missing some curly brackets, some curlies. Don't want to forget your curlies. And it gave me a value, which is 4071. Oh, and I'm breaking after the first line. That's why that is such a small value. $940,000. Oh, wow. Okay. That was a complex piece of code right there, but we got the gold star on the first shot, which is pretty nice. I do wonder if there's a more brute force way of doing this that just involves a lot more nested loops. But I'm actually kind of pleased that this analysis actually worked out as well as it did. I didn't actually expect it to go in the first shot. Anyhow, I think that does it for day 8. We will see what fresh hell will break loose in the evening of day 9, given that the difficulty ramp is pretty significant today. But I think other than like kind of just like getting the problem in my head and then kind of wrestling with some Rust idiosyncrasies here and there, or just my own incompetence at Rust, this one wasn't super bad. And I'm actually pleased that the debugging went as smoothly as it did, which is always really nice. Okay, well, I will see you probably not tonight because we're doing our game stream tonight. But we'll probably pick up day 9's problem on the actual day 9, which is tomorrow. All right, take care, everybody.